In a revealing update that has captivated the global spaceflight community, SpaceX has confirmed that a dramatic explosion at its Starbase testing facility in Boca Chica, Texas, was caused by the rupture of a high-pressure nitrogen tank used in ground support operations. The incident, which occurred during routine systems checks on a test stand, absent of any flight hardware, unleashed a massive shockwave that reverberated across the site and was captured by numerous independent live streams and surveillance feeds. Although no personnel were harmed and no spacecraft damaged, the blast underscored the immense risks associated with the scale of testing needed for SpaceX's ambitious Starship development program. The explosion, which happened in the early hours during what SpaceX described as a non-flight cryogenic test, instantly caught the attention of engineers, aviation authorities, and thousands of spaceflight enthusiasts watching live. The test stand was reportedly undergoing a high-pressure nitrogen purge test, a standard procedure used to verify the integrity of plumbing and pressurization systems designed to manage extremely cold or volatile fluids such as liquid methane and liquid oxygen, two of the primary propellants for the Starship and Super Heavy rocket stages. Nitrogen, though chemically inert and non-flammable, is stored in compressed form at very high pressures, and any failure of containment can unleash the explosive force of a small bomb. Footage of the incident shows a sudden rupture followed by a roaring blast, with dense vapor and debris engulfing the surrounding area. The shockwave was significant enough to rattle nearby structures and trigger automated alerts from environmental and safety monitoring stations. Within moments, emergency protocols were activated, and SpaceX ground crews swiftly secured the site. The area was evacuated, and pressure systems isolated as a precaution. While early speculation ranged from a methane leak to a propulsion system accident, SpaceX engineers quickly homed in on the nitrogen tank as the culprit. Internal telemetry and surveillance logs confirmed that the blast originated at the tank's base, and metallurgical analysis is now being conducted to determine whether it failed due to corrosion, manufacturing defect, or overpressure beyond design tolerances. SpaceX's official statement described the anomaly as contained and non-critical to launch vehicle readiness, noting that the test did not involve any flight structures, cryogenic propellants, or live engine firings. Nonetheless, the sheer scale of the explosion and its timing, occurring as the company prepares for Starship's next integrated flight test, prompted concern about the integrity of supporting infrastructure and whether similar tanks elsewhere in the system might be vulnerable. According to sources familiar with the matter, engineers are already in the process of reviewing design specifications for all pressure vessels across the Boca Chica complex and have begun recertification protocols to ensure no latent weaknesses exist in other GSE units. The rupture is reminiscent of past SpaceX incidents, most notably the 2016 Amos 6 explosion, where a composite overwrapped pressure vessel, COPV, inside the second stage of a Falcon 9 failed during fueling operations. That incident destroyed the payload and the rocket, delaying commercial and NASA missions by months. In contrast, the current nitrogen tank rupture caused no damage to a Starship prototype or launch vehicle and occurred in a more isolated ground environment. Still, both incidents serve as stark reminders that even the most routine pressurization systems can pose catastrophic risks when operating under extreme conditions. The role of nitrogen in the test environment is typically non-reactive. It's often used to displace oxygen, reduce fire risk, and cool or pressurize lines without chemical volatility. However, when stored in tanks at thousands of psi, the failure of a seal, weld, or valve can lead to an uncontrolled decompression event, essentially transforming the tank into a fragmentation device. The fact that this occurred during an off-nominal system check, with no launch scheduled and no live propellants on site, ironically illustrates the necessity of rigorous validation procedures for even the most benign-seeming components. In response, SpaceX has launched a full-scale investigation with cross-team collaboration involving tank fabrication, materials science, and cryogenic systems specialists. Every pressure tank of similar design is now subject to inspection, and new sensor packages capable of measuring microfractures and stress in real time are being considered for integration into the site's broader instrumentation grid. The incident has also triggered a renewed discussion within the aerospace industry about the importance of ground support equipment, a field often overshadowed by rocket engines and flight dynamics but absolutely critical to launch success. Despite the incident, SpaceX remains confident that the Starship program will stay on track. The company emphasized that its broader roadmap, including the FAA licensing process for the next orbital test flight, remains largely unaffected. In fact, work has already resumed on Starship hardware construction and stage integration just a few hundred yards from where the explosion occurred. The company's iterative design approach, famously championed by CEO Elon Musk, embraces failures as data points, part of a larger strategy to accelerate learning and improve system resilience. Musk himself responded to questions online with his characteristic candor, noting that progress involves risk, and that engineers had already identified ways to prevent similar tank failures in future designs. The Starship program, once considered a bold vision for the distant future, has rapidly become central to NASA's Artemis moon landing architecture, global satellite deployment ambitions, and the long-term dream of interplanetary travel. With a thrust capacity exceeding any vehicle in history and a fully reusable design, Starship aims to revolutionize launch economics and scientific exploration. But with that scale comes commensurate risk, and incidents like the nitrogen tank rupture are stark illustrations of the obstacles that must be overcome to realize the dream of sustainable human presence beyond Earth. As regulatory agencies like the FAA and EPA continue monitoring developments at Starbase, particularly in light of environmental concerns and community impact, SpaceX has reiterated its commitment to transparency, safety, and continuous improvement. Community leaders in Cameron County, where Starbase is located, expressed support for the company's response, noting that no evacuations or emergency services were required. Still, residents voiced concern over the intensity of the blast, reigniting debates about the risks of operating such powerful test systems in proximity to populated areas. In the final analysis, while the nitrogen tank rupture caused no mission-critical damage, it served as a potent reminder of the high-stakes nature of modern rocketry, even during ground-based support operations. The lessons learned from this explosion are already shaping future infrastructure design at Starbase and beyond. SpaceX's ability to quickly investigate, adapt, and enhance safety protocols ensures that this incident, like many before it, will ultimately strengthen the foundation upon which Starship's future missions to the Moon, Mars, and beyond are built. Tools. ChatGPT.